Hello, 7th graders. Thanks for checking out this video tutorial on rates and unit rates. This is section 2 of chapter 5. Today your learning target is I can use unit rates to solve rate problems. So right away we're going to talk about what a rate and what a unit rate is. Okay. So first, a rate is a ratio of two quantities using different units. So for example, one of the most famous rates, ratios, so we're comparing two things that I think you might have heard of. One of the most famous ones is like miles per hour. Okay, notice how we're using different units. I'm using miles and hours. Say we're traveling 60 miles in 2 hours. This is an example of a rate. A unit rate compares a quantity to 1 unit of another quantity. So for example, if I were to change this into a unit rate, sorry, there should be a space there. That would mean I want to know how many miles do I go in I want to compare it to 1 unit in 1 hour. I don't want to know how many miles I can go in 2 hours. I want to know how many miles I can go in 1 hour. Well, to go from 2 hours to 1 hour, I divide it by 2. So if I divided by 2 on top, I would get 30 miles per hour. Okay, so this would be like an example of like a town limit speed. You can't go fast in town. The speed limit is 30 miles per hour. Okay, so here's a rate, here's a unit rate, and it says equivalent rates have the same unit rate. Okay, or you can make them the same unit rate, right? For the numbers portion of it here, it says you pay $350 for every quarter ounce of gold. And if you wanted to make that into a unit rate, well, if it's $350 for a quarter of an ounce, we don't want to know how much money it is for a quarter of an ounce. We want to know how much money is it for 1 ounce. So to go from a quarter to 1, you just have to multiply by 4. So if I multiplied 350 by 4, that would give me, well, there, did it here for you, but $1,400, $1,400 per ounce of gold. That's a lot of money. You might know that an ounce is extremely light to us, and for $1,400 for 1 ounce, that's an extreme amount of money. But you guys know that gold is worth a lot, right? Just a reminder, for a rate, you can write it using a colon, or you can write it in fraction form. So this is a rate, and this is also a rate. Notice how one is written using a colon, and one is written in fraction form. All right, so we have rates and unit rates. We'll get some practice with those here, this section. Example 1 says a nutrition label shows that every 1/4 cup of tuna, for every quarter cup of tuna, there is a 1/2 gram of fat. Okay, so you can imagine a quarter cup, what that kind of looks like. I'm sure you know what like a measuring cup looks like. A quarter cup is, well, 1/4 of that. There's a 1/2 gram of fat in that much tuna. Letter A says, how many grams of fat are there for every cup of tuna? So it wants to know for every 1 cup of tuna. Well, I know that in a 1/4 cup, there's a 1/2 gram of fat. But this is saying, well, how many grams of fat are there in 1 cup of tuna? Okay. Well, how could I compare these two? Well, I know that 1, to go from 1/4 to 1, I just multiply by 4. It's 4 times as big. So if I just multiply my grams of fat by 4, I will figure out how many grams of fat there are in 1 cup. So a half times 4, well, what's half of 4? That would be 2. So there would be 2 grams of fat for every quarter cup of tuna. Okay. Now, you could think about that like I did here, or you can write it as a fraction, right? It wants it wants to know. You could write it like this. There, it wants to know how many grams of fat there are in 1 cup of tuna, and what we're given is that there is a half gram of fat for every quarter cup of tuna, right? So it wants to know, remember, a unit rate has this denominator of 1. So how do I go from a fourth to 1? Well, I just multiply by 4. So I multiply by 4 on top, and a half times 4 gave me 2. So you can kind of write it like that. The other way that you can do that is you can just divide, right? This is the same right here as a fraction. That's 1/2 divided by 1/4. And you guys know how to divide fractions. You just keep, flip, flop. 4 times 1 is 4. 2 times 1 is 2. 4 divided by 2 is 2. And I got the same answer that way. So essentially what I'm trying to show you right here is that there's lots of different ways that you can find a unit rate. Letter B is a little bit different because now it says how many cups of tuna are there for every gram of fat. Okay, so I know that a half gram, a half gram of fat, there's a quarter cup of tuna. And it says how many cups of tuna. So I'm looking for how many cups of tuna there are for every 1 gram of fat. Well, ask yourself, how do you go from, what's the relationship between a half and 1? How could we go from a half gram of fat to 1 gram of fat? Well, we could just double that recipe, or we can multiply it by 2. So I'll do the same here, multiply it by 2, and a quarter times 2, 1/4 times 2, which is 2 over 1, gives you 2/4, which is a half. Okay, so how many cups of tuna are there for every gram of fat? For every 1 gram of fat, there's a half cup of tuna. Okay, so lots of different ways. Essentially, you're just keeping these 2 ratios proportionate. Why don't you go ahead and pause and try it here, number 1, please. Alrighty, it says there is a quarter gram of fat for every 1/3 tablespoon of powdered peanut butter. It wants to know how many grams of fat, so that I'm going to keep my grams of fat on the top, are there for every 1 tablespoon of powdered peanut butter. Okay, well, how do I go from 1/3 to 1? What's that relationship? Well, it's just 3 times as big. I just multiply by 3. So to keep this ratio proportionate, I need to multiply my numerator by 3 as well. So 1/4 times 3 would just give me 3. 1 times 3 is 3. 4 times 1 is 4. 3/4 grams of fat for every 1 tablespoon of powdered peanut butter. That's interesting. I've never had powdered peanut butter before. I wonder if it's any good. All right, example 2 says that a scientist estimates that a jet of liquid iron An Earth's core travels 9 feet for every half hour. How far does the iron travel go? How far does the liquid iron travel in one day? All right. For this one, I'm going to set up a ratio table and show you that a ratio table, like we did last section, will work too. So I'm comparing distance and time. And my time is in hours, and my distance is in feet. Okay, here's my ratio table. I know that for every 1/2 of an hour, I can go, or not I, but that iron travels 9 feet. It wants to know how far does it go in one day. Well, what I think would be helpful first is finding out how far does it go? How many feet can it go in not a half hour, but 1 hour? Let's find that out. So to go from half to 1, well, I just doubled it, multiplied by 2. So I need to multiply by 2 on top to keep my ratio proportionate. 9 times 2 gives me 18. So that means the liquid iron travels 18 feet per hour. It wants to know how far does it go in one day. Well, how many hours are there in a day? There are 24 hours in a day. So how can I go from 1 hour to 24 hours? I can just multiply by 24. To keep this ratio proportionate, I need to multiply my numerator by 24 as well. Okay, so take 18 times 24, and that should give you 432 feet that the liquid iron travels in 24 hours, which is the same as one day. So 432 feet. Go ahead and pause here for the try it number 2. All right, it says the scientist later states that the iron travels 3 feet for every 10 minutes. Does this change your answer? And explain. All right. Well, let's compare a unit rate. So let's try to get my minutes to 1 hour and we can compare. So I know that if I were to multiply this by 6, that would give me 60 minutes, which is the same as 1 hour. Okay. So if I multiply my denominator by 6, multiply my numerator by 6, and that gives me 18 feet. So 18 feet per hour, 18 feet per hour, are those the same? Does this change your answer? No, it doesn't. It's the same answer. You could say the rates are equivalent. Okay, we're still moving at 18 feet per hour. Alrighty, last example, and then a couple practice problems here to wrap up today. It says you hike up a mountain at a rate of 1/4 mile for every 10 minutes. You hike 5 miles for every 2 hours on the way down. It would make sense that it would take you a little bit longer to go up than down. It's a little bit more work. It says, how much farther do you hike in 3 hours on the way down than in 3 hours on the way up? So what we're going to compare is how far we can go in 3 hours. And we're going to compare that going up versus going down. Okay, so let's look at going up. I know that I can go 1/4 of a mile in 10 minutes. right, in 10 minutes. Now, I'm going to think about that as a fraction in terms of hours, so I can, because it's talking about hours here. So how much is 10 minutes compared to an hour? Well, if there were 6 10-minute sections, it would give me 60 minutes, which is 1 hour. So 10 minutes would be 1/6 of an hour, right? If I multiply this by 6, it'd be 1 hour. So I'm going to make 10 minutes the same as, so I can go a quarter of a mile in 1/6 of an hour. From here, let's find out how far I can go, not in 1/6 of an hour, but 1 hour. So how could I go from 1/6 of an hour to 1 hour? Well, I could just multiply by 6, right? If I took 10 minutes times 6, that'd give me 60 minutes or 1 hour. So if I multiplied my hours by 6, I'd also have to multiply my miles by 6 to keep this proportionate, which would give me 6/4 of a mile. Or if I simplified and I divided by 2 on top and bottom, it'd be 3/2 miles, which, remember, 3/2 is just the same as 1.5. So 1.5 miles in 1 hour. But again, we don't want to know how far we can get in 1 hour. We want to know how far we can get in 3. So it's super easy to go from 1 hour to 3 hours by just multiplying by 3. All right, so I'll multiply this by my miles by 3 as well. So 3/2 times 3, 3/2 times 3 over 1 just gives me 9/2. And 9 divided by 2 would be 2 goes into 9 4 times, and there's 1 left over. So we can go 4.5 miles in 3 hours on the way up. Okay, let's compare that to when we go down the mountain. I know we can go, let's see, it tells me 5 miles for every 2 hours. Let's make 2 hours to 1 hour, just like we did here, got it to 1 hour. So I just divide by 2. So I divide my miles by 2. So 2 goes into 5. Let's see, that'd give me 2.5 miles per hour. So compare this. On the way down, we're going 2.5 miles per hour. On the way up, we're going 3/2 is the same as 1.5 mile per hour. So we're going 1 mile per hour faster on the way down. And again, I'm going to multiply this by 3 because I want to know how far I can go in 3 hours. So multiply by 3. So 2.5 times 3 would give me, let's see, that'd be 7.5. So 7.5 miles in 3 hours. Okay. So compare the difference here. Here I can go, when I'm going up, it takes me, or I can go 4.5 miles in 3 hours. When I'm going down, I can go 7.5 miles in 3 hours. So it says, how much farther do you hike in 3 hours? Well, what's the difference between 7.5 and 4.5? Well, that would be 3 if you subtracted those. 3 miles farther in 3 hours on the way down. And that makes sense, like just what we talked about. You can go a lot faster walking down a mountain than you can walking up. Okay, go ahead and pause to practice finding the unit rate for 5 and 6. All right, for number 5, it costs $1.32 for 12 ounces. It wants the unit rate, so it wants to know how much money does it cost for not 12 ounces, but per 1 ounce. Remember, unit rate has that denominator of 1. Might want to write that down. It's easy Easy to forget that. So how do I go from 12 ounces to 1 ounce? Well, I just divide by 12. 12 divided by 12 will give me 1. So I need to divide by 12 on top as well. Okay, so $1.32 divided by 12. 12 goes into 1 0 times. Bring my decimal straight up. 12 goes into 13 once, which is 12. Subtract. 13 minus 12 is 1. Bring down my 2. 12 goes into 12 one time, which is 12, so I'd have nothing left. So this comes out to 11 cents per ounce. 11 cents per ounce. And then for number 6, I have 1/4 of a gallon for every 3/10 of a mile. Remember, I did it like in example 1. The other thing you can do to solve these is you can just divide them, right? This means divide. So this is the same thing as 1/4 divided by 3/10. Okay, which is the same as keep, flip, flop. Okay, I'm going to simplify first. So divide each of these by 2 would give me 2 and 5. And then I'll multiply across. So 1 times 5 is 5. And 2 times 3 is 6. So I have 5/6 of a gallon per every 1 mile. 5/6 of a gallon per mile. Alrighty. Let me know if you have questions on either of those. And that does it for this section of Chapter 5. So this was Section 2 again with rates and unit rates. Please let me know if I can help out more. And I will see you guys next time.